So since Sarah has such an issue with having two sheets of paper on her desk, I did not print this one out for you guys. Uh, but it's really simple. And what we're going to work on today is molar conversions using a mole to mole ratio. So yesterday we learned about this step, right? I'm just making sure everyone's still alive. That step right there, the mole to mole. You don't have this, but that's okay. And whenever we do mole to mole, maybe you hopefully can read this. And what does it say right there? Can anyone read that? The mole ratio is a little star, is from the balanced equation. Okay, so this is what we did yesterday. Today we're going to add a little bit to it. And where we're only going to go today is we're going to add this arm and we're going to add this arm. But here's what I need you to understand, is that are there other types of molar conversions other than just using grams? Yes, okay. You can talk about milliliters of solution, you can talk about liters of solution, you can talk about milliliters of a gas, or you can talk about liters of a gas, and you can also go to those things. So the way this works is this is the information that you are given, and this is the information that you are asked to find. And so this is just kind of a flow chart of how you do it and where you go, and it would kind of make sense if Sarah would let me print this out and give it to you and have an extra sheet of paper on your desk. But again, when we're through this, you really don't even need this. It's just kind of a waste of space because it'll make sense once you see it. So let's actually look at one of the problems. So the reason I actually like this sheet is because that's not the right sheet, it's this sheet. Kind of looks like an ugly butterfly. Okay? So I want to be able to use reactions and be able to do stoichiometry. And again, so stoichiometry is going to be the conversion factor of this. Now, some of you look at this and grunt with almighty anger when you read these words. Okay? But I'm going to help you out with these first few and just kind of make sure everything makes sense. So it says potassium chlorate decomposes into potassium chloride and oxygen gas. All right, so if you have enough room, I'm going to write it up top. I'm going to make it a little harder than it has to be in the beginning, but that's okay. It's not always bad. Potassium, what group is that in? Group 1, so it's, you want to try that again? Okay. All right, chlorate, what is chlorate? ClO3 what? Negative. All right, so what do plus 1 and plus 2 do? Excuse me, what does 1 plus and 1 minus do? Cancel. All right, so we've got K, ClO3, and then it says here's your action. It decomposes. So what's fixing to happen to this thing? It's fixing to break apart. All right, so we have our arrow. It decomposes into potassium chloride. All right, so there's a compound. So potassium's still in group 1. Now what group is chloride in? 17, which is what? 1 minus. Well, what does 1 minus and 1 positive do? Cancel out. So it's plus KCl. And then it says, and oxygen gas. So if I wrote it like this, would I be right or would I be wrong? I would be wrongo. Why? Oxygen gas is a diatomic, which means it has to have how many of them? 2 of them. Okay. All right, so now my question is it balanced? No, take 30 seconds. Balance. This is an easy balancer. Think about the 2-3-6 rule. Excuse me. Did you get 2-2-3? Good. Real easy, right? Not too terribly difficult to do that one. All right, so here's the question. It says how many moles of oxygen? So, and I want you to actually do this. What are they specifically asking you for? So do this right here. So put a little question mark underneath oxygen and write the word moles. You okay with that? So how many moles of oxygen are produced when 3 moles of potassium chlorate decompose completely? All right, so what's your given? 3 moles of potassium chlorate. So underneath this, write 3.0 moles. Now, I'm going to go back to the screen just to show you, to make it a point of emphasis. So, my question to you is, what are you given specifically? What unit were you given? Do you agree that we were given moles? Okay. What specific unit were you asked to find? Moles. So how many steps should we have? One step. Can we go from moles to moles? Yes, fantastic. So let's go back. Let's pull this back up, and let's do it. All right, so we're starting with 3.0 moles of what? KClO3. I'm just going to stop there and let you catch up. Now, what's on top must go where? On the bottom. So let me ask you something. Can I go from moles of KClO3 to moles of oxygen? Yes. This is called the what to what step? The mole to mole. And I've already screamed it at you several times. I screamed it at you yesterday. Where does that step come from? So, if you didn't write this down yesterday, it may be beneficial. The mole to mole comes from the that thing. If you're writing it, I'm going to go ahead and put in attendance so I don't forget. All right. So again, the mole to mole comes from the coefficients of balance equation. So Sarah, what is the coefficient of oxygen? Shh, shh, shh. Thank you, ma'am. Zeba, what is the coefficient of potassium chloride? Thanks, Zeba. I'm sorry. Thank you. All right. Zeba, what deep voice you have. All right. Now, this is a really... Did you hear Sam answer for you? Sam answered for you. That's why I said that. Because I said Zeba, and he answered. Now, does it make sense? That's why I said deep voice. Okay. Gotcha. All right. Now, this can be done, hopefully, in your brain. What do you do across the top? So 3 times 3 is 9. 9 divided by 2 is 4.5. Very good. So your final answer is 4.5, and that is it. Very good. Thank you. That's wrong. It's moles of O2. Moles of O dose. What'd you miss? Okay. Again, what step are we at? Mole to mole. All right. The mole to mole comes from the coefficients of a balanced equation. Okay. So when I go back to this, the coefficient of oxygen, which is on top, right, is a 3. All right. The coefficient of potassium chlorate is a 2, which is also right there. So does that help? Okay. So that's literally all you do is find the balanced equation and plug the numbers in. The reason this is a little bit different from everything I've ever taught you is because before yesterday, whenever you saw a mole, what did you put beside it? A 1. Well, now this is just a mole to mole step, and all you have to do is just get the coefficients. So that's, yes, sir. Yes, if it's with grams, it's still a 1. But when it's mole to mole, and again, that's something that we're just kind of have to work through so you see it enough. Matter of fact, the next problem takes care of that. All right, so let's look at the next one. It says butane undergoes combustion. Now, some of you got this, some of you didn't on the balanced equation part. I gave you a rule for balancing combustion. What was it? Double the hydrocarbon, balance is needed, and reduce. Go ahead and balance that one if you can. Take just a second and balance it. All right, so did you get 2, 13, 8, and 10? Now, here's the deal, and I'm finally proving to you that the doubling thing works because had you started with a 1 there, you would have had to put a 4 there you would have had to put a 5 there, and you would have did all this math and said, crap, I can't get it to work. Well, if you go ahead and start with the 2, and you go ahead and balance it, guess what? You're already done. You don't have to redo the work. Everything's done. But is it easier to reduce and have to rework the whole problem? Much easier. So this is why I teach this method. So again, the reason I showed you this part, there was 16 oxygens here, 8 times 2. There were 10 oxygens there for the 10, so that's 26 total. Well, what's half of 26? 13. And why can't any of those numbers be reduced? The 8 and the 10 can be reduced. 13. Some of you actually messed that part up on the test. There was one, it was 8, 8, 1, and 16. And y'all reduced to 8, 8, and 16. Do you remember that? But you couldn't reduce it at all because one of the values was a 1. It was the one with the S8. Okay. All right. So, again, it was 2. It was, thank you, 13, 8, and 10. All right. So, let's see what we got. How many grams? So this is a little bit different. How many grams of CO2? Do you agree that is the question? So, let's come over here and let's put question mark. Grams of CO2 are produced when 88 grams of oxygen are reacted. Now, there's 2 other things I need to mention before we move on. It says 88 grams of oxygen, so we're going to start right here. So we're given 88 grams of this stuff. And there's a word I need you to circle. When we are given 88 grams of oxygen are reacted with an, circle this word right here, excess. We're given an excess of butane. What does that mean? You have more than enough. It's unlimited. There's a new word that I need you to now know. And oxygen. Do you agree that oxygen is the other reactant in this thing? Do me a favor. Above the word oxygen, please write this. This is called the limiting reactant. And we'll talk more about that in depth later, but I'm go ahead and just throwing one of those Velcro balls at you. I need to say they're Velcro bowling balls. Maybe it'd knock some of you a little bit harder. Can we change that? What? It's only the school doing it to me. Now, what is the difference between limiting and excess? Limiting, it runs out. So let's pretend that this weekend we were all going to get together and cook some hamburgers. If you don't like hamburgers, I'm sorry, we're only cooking hamburgers. So let's pretend that Dustin was in charge of getting the hamburger buns and I was in charge of getting the hamburger meat. But we did not communicate about how many we were going to cook. So here's the deal. Even though we did not communicate, and I went and bought my own amount of hamburger meat and he went and bought his own amount of hamburger buns, would one of us buy too little? Yes, that would be considered the excess or the limiting. The limiting. Whichever one runs out first limits how much you can make, right? So you basically, I can't make any more hamburgers because I'm out of one of the 2. And with stoichiometry, you can actually determine it mathematically. But in this case, we don't have to yet because it tells us which one we have more of. Which one do we have unlimited amounts of? Butane, because it tells you. And we'll get to one of the problems where we have to say, okay, I have so much of this and so much of this, I don't know which one to run out first, and we'll talk about that in a second. All right, so I'm going to pull this page back up just so we can make sure that we're all on the same page. Good, fantastic. So, what unit was I given in this problem? Grams. What was I asked to find? I was asked to find grams. All right. So the first thing I have to do is to get to moles, right? That's the first step. What's the next step? I got to go from moles to moles. Would you agree? And can I stop right there? And then the last step is I've got to get from moles to grams. And here's the best news of the day. This is the most complex problem you'll ever see, and it's 3 steps. It doesn't get any more difficult than this. Say it again. Ignore this. These are other types of problems that I could give you, but we're not going to get into that this year. We're only going to stay on the top. Okay. So for this year, we're only at the top 2. Question? Okay. Just making sure. Just making sure. I don't want to leave anyone out. All right. So let's start with what we know. We were given, start as far left as you can go, by the way, just to conserve your space. We're starting with 88 grams of oxygen. Now, you've done these before, so don't act like you've never seen this. If grams of O2 is on top, where's it got to go? It's got to go to the bottom. Now, anytime we were ever in grams, what was the next thing we always had to go to? Had to go to moles. So we got to go to moles of O2. Now, I'm going to fill this in before we can finish. But why can I not stop with that step? What was the question asking me for? Grams of CO2. I'm only at what? Moles of O2. I'm not even in the right compound. Nonetheless, not even in the right unit. Now, what is moles with here? Grams. This is the most important thing for transition of students for you to understand. When and when only do you use the coefficients? Is this mole to mole? No. So this is the old rule. So what does a mole get? A 1. Where do grams come from? Periodic table. This is a tricky one. Matter of fact, my AP kids had a question very similar to this on the AP exam, and it screwed some of them up because the question asked about I2, and they forgot to double the mass. What is 1 oxygen? But this is how many? This is 2 of them, so it's 32. The question, it was a basic stoichiometry, and it asked about I2, and they looked up there, and iodine's 126.97, and they forgot to double it. So some of them missed it because of that. Again, this is one of those tricky ones that you really have to catch. So it's 32.0 grams. All right, so we know that grams of oxygen cancels. I may not have any clue of where I'm going or how to get there. But do you agree that I've got to get rid of moles of O2? Where can I put it? On the bottom. So I've got to go to moles of O2. Thanks, Sarah. But this is where this sheet would have a huge benefit. Okay. We've gotten to moles. Do you agree? So we are at this step right here. Well, what's my next step? I got to go to the moles of the next compound. So I used to have a phrase. The only way to convert from one compound to another is going mole to mole. And you'll see that in just a second. So here's what we have. Then this is the new step. This is the one you haven't seen before. So we've got moles of, what are we trying to go to? Carbon dioxide, CO2. So let me say it one more time now that you see it. The only way to go from one compound to something totally different is through what step? The mole to mole step. Is O2 and CO2 totally different? This is the only way we can convert from one to the other. Now, again, the mole to mole step comes from the coefficients of the balanced equation. So what is the coefficient of oxygen? 13, wow. Thank you. And what is the coefficient of carbon dioxide? 8. So in this step, it is 8 over 13. Now again, I told you that this is the most complicated problem that you guys are going to see, and it's 3 steps. Would you agree that moles of O2 now cancels? So that's out. And you know the answer to this. Why can I not stop and put equals and write an answer? It asked about what? It says how many grams. And again, don't freak out. It's the last step, and it's almost the exact same as the first. I know I need to get rid of moles of CO2, so I can put it down here. And finally, I can get to grams of CO2. Is mole with moles here? No, it's with what? So what does the mole have to get? Has to get a 1. Now, you probably don't know the molar mass of carbon dioxide, but I do. It's 44.01. I will be honest with you. You will get the masses. I will not make you calculate them. Okay? I would rather you do this right than screw the mass up and get the wrong answer. So I'm going to give you the masses. You don't have to worry about that. Now, you just have to figure out how to calculate it. But what do you do with all the numbers on top? Multiply. And what do you do with all the numbers on bottom? Divide. So give me 1 second. Let me pull up my handy dandy calculator. What? Does she really? Oh no. Alright, so I've got 88 times 8 times 44.01 equals, divided by, I'm going to use my parentheses, 32 times 13, close it, and there's my answer. Now, you know you can't write that whole ridiculous thing down, right? What was the only number in the question? 88. So how many sig figs is that? So what's your answer? 74. So 74 grams of carbon dioxide is produced. 74 grams of carbon dioxide is produced. Any questions? All right. So this next one, 5 and 6, I am going to help you with a balanced equation, and then I'm going to see if you guys can do 6 on your own, and we'll come back together to do 7, and we'll call it quits. Now, it says water decomposes. So what's the first thing you got to write? Water, H2O, and it's breaking down. And it says it breaks into hydrogen gas and oxygen gas by electrolysis. What is electrolysis? Electricity. Okay. Now, so if I wrote hydrogen and oxygen gas, would I be right or wrong? Wrong. Very good, because those two things are what? Diatomics. Now, my second question, is it balanced properly? No. I need a 2 in front of the water, and I need a 2 in front of the hydrogen. So that gives me 4 H's on each side and 2 O's on each side. Yes, sir. Okay, think about this. When they're with a compound, they are sharing their electrons with someone else. And depending upon who the more electronegative element is, dictates how those electrons are going to be distributed. When they're by themselves, they need a partner to make them more stable. Does that make sense? I understand. But, all right, remember how I told you I've been lying to you? All right, ionic bonds really don't exist. They're extremely, extremely strong covalent bonds. They're just so strong, they get a new name. Because technically the electrons are kind of still being shared. All right, try number 6. Yes. Last year or last semester? Yeah. All right. So I am going to need your help on this. How many grams of what we're given? Or moles of what we're given? Okay. So I've got 6.0 moles of O2 we're given. All right. Like I said, I may not know where I'm going, but I know where I can start. So I know that I've got to get rid of moles of O2. So based on this sheet of paper, where were we given our information? We were given to them in moles. Well, according to this, what's the next thing that bridges our gap to the other side? Moles, okay? So I know that I can now go to moles, and what are we trying to get to? Moles of H2. All right? Now, again, your mole ratio comes from the balanced equation, and you can barely see it, but it should be 2 over 1. And then finally, the last step, because the reason I can't stop, because the question asked me specifically about grams, correct? All right, so I know that I need to cancel my moles of H2, and I can finally go into grams of H2. And just like the rules we've always done, if moles is with grams, what does mole get? A 1, where do grams come from? The periodic table, so it should be 2.02. And so when you multiply 6 times 2, that's 12. And 12 times 2.02 is 24.02. But what do we do with that 0.02? We drop it because we only need 2 significant figures. So it's 24 grams of H2. 24 grams of H2. Yes, sir. You're right. My bad. That was stupid. But his answer is still 24. All right, so let's look at the last one. And this is going to be just like number 4. I promise there's not. Oh, you're talking about erasing? I thought you were talking about stoichiometry. All right, so we've been given 9 grams of hydrogen, and the question is how many grams of water are required. All right, so now we're going from what step to what step? Grams to grams. So this handy dandy sheet, we are starting, matter of fact, it's already been highlighted and colored for us. We were given grams in green. We've got to go from grams to moles, and then we got to go from mole to mole, and finally we got to go to mole to grams. So it's going to be 3 steps. That's the wrong button. Let's go back. Pull this up, and we're good to go. All right, so we've got, and I'm going to go ahead and fill everything out before I plug any numbers in, if it will cooperate. If it will cooperate. All right, so I've got grams of H2. Now I've got to go to my moles of H2 first. All right, and after moles of H2, and I promise I'll move in just a second. Once I'm in moles of H2, can I go to moles of water? Remember, to go from one compound to a totally different compound, you got to go to moles. Moles of H2O, and then finally I can do grams of H2O. What numbers up there guaranteed will always be 1? No. So this one and this one. The reason those will always be 1 is because they're with grams. Okay. Where does that middle step come from? The coefficients. And what is the coefficient of both of these compounds? 2. Now let me ask you something. Mathematically, what happens in that step? It cancels, but do you still have to show it? Yes, because it won't always cancel, so you still got to show it. All right, so grams of H2 is 2.02. The only compound's mass I've asked you to memorize all year is water. What is it? 18.02. It's the only one I've asked you to memorize all year. Okay, so let's pull out the calculator and let's see what we get. All right, so we've got 9 times 18.02 equals divided by 2.02. Now my first question is, why did I leave out those 2's in the middle? They're a waste of time. So that's the whole big answer. How many significant figures are in the given? 3. So you should have 80 point what? 3 is your answer. So you get 80.3 grams of water for every 9 grams of hydrogen. .3 grams of water for every 9 grams of hydrogen. So you have learned stoichiometry. Did you really? Well, the only number that's well, yeah, the top 2 on the middle and right one, they'll change.